everyone, this is lesson 3.4. The objective for today is how important perceptual interpretation is to our experience, and we're focusing today on the hearing, the perception of hearing. So, how is it that we hear? Well, much like seeing, we deal with waves, but instead of sight waves or visual waves, these are sound waves. So, what is going to happen when you hear is a sound wave is going to travel in, and we're going to make really big ones because I'm going to explain why this is important in a second. So you're going to have sound, whoopsies, didn't want to move that. There we go. Sound waves are going to travel in through your ear, or not. There we go. Travel in through your ear and through the auditory canal. So then what happens with the auditory canal is once it hits that, it's going to hit your eardrum. Okay. And your eardrum is right there. It's that little thin membrane that you don't want to puncture. And when it hits that membrane, that vibrates, and it's going to cause vibrations through your middle ear bones. What we know is the hammer, the anvil, and the stirrup. And these are the middle ear, they're little bones, and they are going to vibrate as well. And when they vibrate, it sends waves. The stirrup, you can see the stirrup is hitting your inner ear right there. And what it's doing is it's actually sending these waves through your cochlea. And inside of your cochlea, you actually have tiny itty bitty little hairs. And when these tiny little itty bitty hairs vibrate or move, it sends a message to your cochlear nerve, which then is going to go to your temporal lobe. And these tiny little hairs are attached to what we call the basilar membrane. And the basilar membrane is what takes and transduces. Remember we talked about transduction? It's going to use transduction to then transduct that sound wave into your cochlear nerve so that your auditory receptors in your temporal lobe can process that information. So we're going to take a look at these waves again. Pitch. So when we hear pitch, pitch deals with the frequency of the wave. So how fast is this wave coming in? So when you hear something, a really high pitch noise, so when dogs can hear, it's because they can hear a higher frequency than we can hear, right? Volume is going to be the amplitude of the wave. That's why we call it an amp, right? Amplitude of the wave. One of the other cool things about hearing is how we determine location or where sounds are coming from. And the way that we're able to detect that is because the sound wave will hit one ear first. Oh, one ear, sorry, I should say one ear first. This is why when you're traveling like in a city or a more urban area and there's a lot of buildings around and you hear a fire truck or an ambulance, you hear it, but you can't tell what direction it's coming from. The reason for that is because of the fact that you can't quite tell what ear it's hitting first because it's bouncing off buildings. So how exactly do we hear? Well, much like the vision or color, we have some different theories on how we hear. The first idea is called place theory. And what place theory is going to say is that we hear based on where the sound wave, the place that it hits the cochlea, or the place that the cochlea, sorry, that's spelled wrong. the place where the cochlea is stimulated. So that's one theory. So how far it bounces back into the cochlea, so let's say if it hits here, or base is right here, can tell us information on hearing. The other idea is the frequency theory. And what frequency is going to say is the speed of the vibrations is what allows us to hear different sounds. So if things vibrate very fast versus if things vibrate very slow inside of the inner ear part, inside of our inner and middle ear, is how we hear. So how do we explain hearing loss? Well, there's actually two types of hearing loss. The first type is conduction hearing loss, and this cannot be repaired. So the first kind is what we call conduction. And once this happens, it cannot be repaired. So we'll just say no repair. And this is when there's been actual damage to the middle ear. That you cannot repair. So these are going to be the three little bones. The second is what we call sensory neural hearing loss. And this is actually can be corrected. This is what we call nerve deafness. So you did something or there was some birth defect where the nerve doesn't function properly. And in this case, so it can be caused by disease, but it also can be caused by a biological change, so like aging or heredity. But this can be corrected. Oh, also prolonged exposure to loud noise. Don't listen to your headphones too loud. Now, this can be corrected by what we call a cochlear implant. And you can see how a cochlear implant works. They actually take a little wire and put it through the cochlea. And then they have an internal implant that helps with process the hearing, which is kind of interesting and fascinating that they can do this. Now, there's another type of, it's not a hearing loss, but another type of phenomenon that deals with hearing. And instead of creating another slide, I'm just going to add it right here. And it's called synesthesia. Actually, I'm sorry, synesthesia. And what that means is that one sensation can produce another. For example, in some people, they can hear a sound, but it also produces a color. So again, this is a phenomenon that deals with sensation. Not everybody has it, but something just to be aware of. So what we discussed today was hearing and the process of hearing, how sound waves travel in through your ear, cause vibrations through the middle ear and the three bones into your cochlea, which is then produced by the basilar membrane into your auditory nerve. We have two types of hearing loss: conduction hearing loss, which is when the eardrum itself has been punctured or the middle ear has been damaged. And then there's sensory neural hearing loss, where there's been actual damage to the inner ear and the cochlea. And that can be treated by what we call a cochlear implant.